Here, question number 33 of GATE 2018 Civil Engineering morning session is discussed. Question is, a cantilever beam of length 2 meter with a square section of side length 0.1 meter is loaded vertically at the free end. The vertical displacement at the free end is 5 mm. The beam is made of steel with Young's modulus of 2 into 10 raised to the power 11 Newton per meter square. The maximum bending stress at the fixed end of the cantilever is. So options are given, and accordingly student has to select the particular option by calculating the maximum bending stress. So given parameters are length of the cantilever beam is given, that is 2 meter, square section of side, that is 0.1 meter, vertical displacement at free end, that is 5 mm. Young's modulus E equals to 2 into 10 raised to the power 11 Newton per meter square. If you just convert into MPa, so that is 2 into 10 raised to the power 5 Newton per mm square, that is 10 raised to the power 5 MPa. To find, that is maximum bending stress at fixed end of cantilever. So here student has to solve this particular question properly. The question setter wants to know whether student can be able to solve this question within a minute or maximum 1.5 minutes. So deflection, if you see the formula, that is delta, which is already given. Deflection, that is of 5 mm, is already given, and we know the formula delta equals to PL cube by thrice EI. So this, the basic formula is to be applied. PL cube by thrice EI. P is unknown, L is already given, that is 2000, and E is also given, that is 2 into 10 to the power 5, while B is given, that is 100, and then D we can take as 100. So from here we can calculate, since delta is already known to us, so P equals to 3125 Newton. Now once we get this particular load, that is 3125 Newton, now we know the formula maximum bending moment. So maximum bending moment equals to P into L, so 3125 into 2, which is also given, that is 6250 Newton. Now since we have to find out bending stress, we know the formula M by I equals to sigma by Y equals to E by R. So if we just calculate sigma max with the formula, that is M by Z, so we will get I by Y. If we just replace this Z by I by Y, that is will be equals to M, moment is already known to us, we have calculated, that is 6250 Newton meter. Similarly, this Y max equals to, now this is since D by 2, so 100 mm is already given, so that is divided by 2. Similarly, I equals to, since it is a square, so this is equals to D raised to the power 4 by 12. So if we just calculate sigma max, so in terms of Newton per meter square, we will get 37.5 raised to the power 6, and if we just convert in MPa, so that is 37.5 MPa. So finally, option number B is correct. So since we have to find out bending stress, so if we just calculate load from the formula, that is delta equals to PL cube by thrice EI, and we can calculate maximum bending moment, so load multiplied by its distance, and then we have to just calculate bending stress, so that is equals to M by Z. So z equals to I by y, and then y equals to d by 2, and I equals to d raised to the power 4 by 12. And once we convert in terms of MPa, we'll get the final option, that is final option B is correct. So student has to solve this particular question within a minute or two maximum, and accordingly he has to mark particular option.